right, hello all, happy weekend. I'm sure you're all watching this on Sunday night. So happy Sunday night. Today in our lecture, we are going to do the second part of 7.2, which is actually doing addition or subtraction with rational expressions. So in 7.2 part 1, we learned about how to find the least common denominator, and hopefully you got pretty comfortable with that because 7.2 part 2 requires us to actually use the least common denominator so we can add and subtract rational expressions. So let me go ahead and share my screen and pull up the guided notes, and let's go ahead and get into it. So our objectives: add, subtract rational expressions with unlike denominators. Our homework is problem set 7.2 part 2 on Math Lab. Video will be posted when it's done. So part 1 and only part is adding, subtracting rational expressions with unlike denominators. And thankfully, we have some steps for this process, okay? And if you are not quite yet comfortable with finding the least common denominator, that's okay, because as we add and subtract rational expressions, we're going to get more practice with it because we need to find the least common denominator in order to add or subtract. And so hopefully with that more practice, you will start to have that click for you. And if not, obviously tutorial, you're all welcome anytime. So our steps for adding or subtracting rational expressions with unlike denominators are that first we need to find the least common denominator, okay? Step 2 is to write each rational expression as an equivalent rational expression whose denominator is the least common denominator found in step 1. Step 3 is to add or subtract our numerators and write the result over the common denominator. So a common error here is that students like to add the denominators. Remember, when we add fractions like 5/8 plus 1/8, that is equal to 6/8. It is not equal to 6 over 8 plus 8, which is 16, right? Our denominator stays the same. We don't add our denominator together when we are doing multiplication or subtract, or when we are doing addition or subtraction. So just a thing to be cognizant of there. And then step 4 is simplify the resulting rational expression. So those are the steps that you want to take each time. And now we're going to go ahead and go through a couple of examples that are addition and subtraction of rational expressions. So number 1, perform indicated operation. We have 2 over x squared y plus 5 over 3x cubed y. So least common denominator, let's list out our factors. We have x, and the highest power we have x2 is 3. We have y, highest power of y is y, and we have a 3. So our least common denominator is going to be the product of all of these. So it's going to be 3x cubed y. Okay, and now what we need to do is we need to take our fractions and we need to rewrite them over the common denominator, okay? And so what you do is you multiply your numerator by what is missing, okay? So what is missing to get your denominator to the least common denominator? So I'm going to rewrite this. We have LCD was 3 x cubed y, and our fractions are 2 over x squared y plus 5 over 3x cubed y. So our second fraction is already over our common denominator, right? 3x cubed y. So we are going to leave this as 5 over 3x cubed y. Our 2 over here is over x squared y. So to get from x squared y to 3x cubed y, we are missing, we're missing a 3 and we're missing an x. So that means that we need to multiply both our numerator and our denominator of 2x2 over x squared y times 3x over 3x. So the thing you're missing has to be multiplied by in the numerator and the denominator. So that's going to give us 2 times 3x, which is 6x over x squared y times 3x will give us 3x cubed y, which is exactly what we wanted. So we're going to have 6x over 3x cubed y. And now we're going to just add straight across, right? So 6x plus 5 over 3x cubed y, because we just add straight across. In our numerators, leave our least common denominator as is. And so our final answer, we can't factor anything out of our numerator. So there's no simplification here. Our final answer is going to be 6x plus 5 over 3x cubed y. All right, let's do another. So number 2, we have 3 over x plus 2 plus 2x over x minus 2. So the two factors we have are x plus 2 and x minus 2. So the least common denominator is going to be the sum, or not the sum, is going to be the product of those two. So our least common denominator is going to be x plus 2 times x minus 2. And now we want to take our fractions and rewrite them over our least common denominator. Okay, and so let's first look at 3 over x plus 2. This guy is missing x minus 2. So we're going to multiply by x minus 2 over x minus 2. So we're going to have 3 times x minus 2 over x plus 2, x minus 2. So this fraction has become 3 times x minus 2. And now let's look at our second fraction. I'm going to color code this a little bit. Let's do it in blue. So we have over here, we have 2x over x minus 2. Again, we have to multiply by what we're missing. So we're missing x plus 2 times x plus 2. So we're going to have 2x times x plus 2 over x minus 2 times x plus 2. So our numerator for our second fraction has become 2x times x plus 2. And now we can go ahead and add straight across, right? So I'm going to erase this so I have a little bit of room, and I'm going to write equals 3 times x minus 2 plus 2x times x plus 2 over x plus 2 times x minus 2. Except for here, we can in fact simplify a little bit. Okay, so we're going to focus on our numerator. I'm going to circle it in red. And we're going to come over here and simplify our numerator. I'm going to have to erase my work over here to do that. So we have, I'm going to distribute. So I'm going to have 3x minus 6 plus, and I'm going to distribute some more, 2x squared plus 4x. And so when I combine my terms, I'm going to get 2x squared. 4x plus 3x is going to be plus 7x. And then that's going to be minus 6 left over. So my final answer, I'm going to have to I'll write it right at the top. So we have simplified our numerator, and that's that final step, number 4. So my answer is 3 over x plus 2 plus 2x over x minus 2 is equal to 2x squared plus 7x minus 6 divided by, or not divided by, it's a fraction, over x plus 2, x minus 2. Okay, final answer to chain. So kind of the trickiest step here and the key to adding and subtracting rational expressions is finding the least common denominator and then multiplying the fractions you have by what's missing to get it over that least common denominator. So we're going to go ahead and do one more example together. So this one's a little bit trickier. We have 2x minus 6 over x minus 1 minus 4 over 1 minus x. So this one is a little bit tricky, but remember that whenever we have 1 minus x or a number minus a variable, we want to factor something out. And the thing we want to factor out is a -1 so that we can flip the signs. Okay, so I'm going to factor, if I have 1 minus x and I factor out a -1, I'm going to be left with -1 times x minus 1. Okay, so I'm going to rewrite this as 2x minus 6 over x minus 1 minus 4 over -1 times x minus 1. Because again, -1 times x minus 1 is equivalent to my original denominator, because look, if I distribute that -1 back in, I get -x plus 1 or 1 minus x, which was my initial denominator. So factoring out that -1 doesn't actually change the problem at all, but now it makes it easier to list your least common denominator, right? Because now you can see that one of your common factor for here is, in fact, x minus 1. And there's another tricky thing that we could do here, because we can rewrite 4 over -1 times x minus 1 as -1 times 4 over x minus 1. Okay, so this is like a tricky little move that we can do. So we can actually further rewrite these fractions that we have equals 2x minus 6 over x minus 1 minus -1 times 4 over x minus 1, at which point we have a common denominator already, so we can just subtract straight across, right? So -1 times 4 is going to be -4. So I'm going to have 2x minus 6 minus -4. Minus a negative is going to give me a positive, so I'm going to just write plus 4 here, over x minus 1. And now I can go ahead and actually simplify that a little more. So this is going to be 2x minus 6 plus 4, -6 plus 4 is going to give me -2. So 2x minus 2 over x minus 1. And now my last step is to simplify, right? So 2x minus 1 minus 2 actually can be factored, right? We can factor out a 2, and then we're left with x minus 1. So if we rewrite our numerator even more, we're going to have 2 times x minus 1. And now we have multiplication in our numerator, and we have common factors in both our numerator and our denominator, which are going to in fact cancel. So my final answer for 2x minus 6 over x minus 1 minus 4 over 1 minus x is just 2. All that work just to get 2 for an answer. Okay, so that is adding and subtracting rational expressions with unlike denominators. Okay, and what I want you to do is these 3 challenge problems. We are going to start with these as our warm-up, so you guys can have kind of like a preview. So you can try these on your own, and then when we do the warm-up, we'll go into breakout rooms. You guys can discuss the steps that you took, or maybe you just say, I tried for 5 minutes, 15 minutes, 20 minutes, and was just utterly confused. But these ones are a little bit trickier, okay? So I want you to go ahead and try them. So number 1, I gave you a hint, and I gave you actually the least common denominator. It should be k plus 2 times k minus 1 times k minus 2. So sometimes those least common denominators get pretty long, but I do want you to go ahead and try these 3. And remember that in order to find the least common denominator, you need to factor. So you might have to reference, your notes on finding the least common denominator before you go ahead and do these problems. But they should be a challenge, but I do want you to give them a shot, and we will go over them together in class time. And other than that, that's all I have for you guys today. So again, email me if you have any questions, and if not, have a lovely rest of your weekend.